All right, we're going to work on multiply binomial radical expressions. This is going to work just the way you would think it does. We've got a binomial right here. We're multiplying it by a cube root of 7. So we're going to distribute. Cube root of 7 times 2. Those are not like terms that 2 is going to come out front. So we have 2 times cube root 7. Cube root of 7 times, this is a negative cube root of 49, so a positive times a negative is going to be negative. And because they're both cube roots, we can multiply those numbers together. 7 times 49 is 343. And then if we think about our cube root numbers, 343 is actually on the list. The cube root of 343 is 7, so we can reduce this one more time. 2 times the cube root of 7 minus 7. These two terms are not like terms because this has a cube root of 7 and this one does not have a cube root of 7, so that's as far as we can simplify that one. All right, now we have a binomial times a binomial. So we've done this before. We're going to distribute the 2x and then distribute the negative root 3. So 2x times 2x is 4x squared. 2x times a negative root 3. So a positive times negative is going to be negative. The 2x is just going to go right in front of the root 3, so you have a 2x root 3. Now we're going to multiply a negative root 3 times a positive 2x, which is going to be negative. That 2x will go out in front of the root 3. Then we have a negative root 3 times a negative root 3. That's going to be positive because of the negative times negative. Square root of 3 times square root of 3 is the square root of 9. Now to simplify, I see the 4x squared doesn't have any like terms to combine with. But here, this term has a root 3 and this term has a root 3, so we can combine those. You've got negative 2x minus another 2x. That's just going to be a negative 4x root 3. And then the square root of 9, we know the square root of 9 is 3, so we can say plus 3. And now, do we have any other like terms? Remember, like terms, this is an x squared. Do we have any other x squareds? Nope. This is root 3. Do we have any other root 3s? Nope. And that's just our constant 3 on the end. There are no other constants. So here's our final answer.